NEC 517.30 C3 pertains to electrical installations within healthcare facilities. This encompasses both the interior and exterior portions of the buildings. The primary objective of this code is to maintain the safety and well-being of patients and personnel during emergency situations, such as fires or power failures. In this specific scenario, the directional board that runs between the two buildings constitutes an integral part of the electrical system that supports an emergency electric pump. As a result, it falls under the jurisdiction of the requirements outlined in NEC 517.30 C3. This section explicitly states that the raceway employed must be a Schedule 80 rigid non-metallic raceway. It's crucial to recognize that NEC 353, on the other hand, governs electrical installations within industrial and commercial settings, excluding healthcare facilities. Consequently, NEC 353 does not apply in this particular context. Considering the information available, the consultant is correct in mandating the use of Schedule 80 HDP roll pipe for the directional bore that connects the two buildings. To elaborate further on the NEC requirements and their implications for this type of installation, let's delve into the specifics of NEC 517.30 and its associated sections, along with relevant articles from Chapter 3 of the NEC that pertain to raceways and cable installations. NEC 517.30 provides comprehensive guidelines for essential electrical systems in healthcare facilities. These systems are vital for ensuring continuity of power during disruptions, safeguarding critical patient care functions. Subparagraph C, titled Wiring Requirements, outlines specific regulations for wiring methods used in these essential systems. Section 3 of the subparagraph, which is of particular relevance, addresses raceway requirements. It mandates the use of either non-flexible metal raceways type MI cable or Schedule 80 rigid non-metallic raceways for essential electrical systems. The rationale behind this requirement lies in the heightened safety considerations associated with healthcare environments. The robust construction of Schedule 80 rigid non-metallic raceways provides enhanced physical protection for the conductors, shielding them from potential damage that could compromise the integrity of the essential electrical system. This is particularly important in areas where the raceway might be exposed to physical stress or impact. Furthermore, Schedule 80 rigid non-metallic raceways offer superior resistance to fire and other environmental hazards. In the event of a fire, these raceways are designed to contain the flames and prevent them from spreading, thereby safeguarding the building's occupants and minimizing property damage. Additionally, the non-metallic nature of these raceways eliminates the risk of electrical conductivity, reducing the potential for shocks or electrocution. The NEC also addresses the installation requirements for underground raceways in Article 300.5. This article specifies minimum burial depths for various types of raceways, depending on factors such as voltage level, location, and potential for physical damage. For instance, direct buried Schedule 80 rigid non-metallic raceways typically require a minimum burial depth of 18 inches to provide adequate protection. It's essential to consult the specific requirements of NEC 300.5 to ensure that the raceway is installed at the appropriate depth for the given application. In addition to burial depth, NEC 300.5 also addresses other important considerations such as backfill requirements and protection from physical damage. The backfill material used to surround the raceway should be free of sharp objects or debris that could damage the raceway. Furthermore, the raceway should be protected from physical damage by means of concrete encasement or other suitable methods, especially in areas where it is exposed to vehicular traffic or other potential hazards. NEC 300.50 provides additional requirements for underground installations operating at over 600 volts. This section mandates the use of shielded cables or other approved methods to minimize the risk of electrical faults and ensure the safety of personnel. It also specifies requirements for grounding and bonding to prevent the buildup of static electricity and reduce the potential for electrical shock. The NEC also provides guidelines for selecting the appropriate size of raceway for a given installation. Article 310.15 outlines the procedures for calculating the allowable ampacity of conductors, taking into account factors such as conductor size, insulation type, and ambient temperature. The raceway must be sized to accommodate the calculated ampacity of the conductors without exceeding its rated capacity. Furthermore, the NEC specifies the maximum number of conductors that can be installed in a raceway of a given size. These requirements are designed to prevent overcrowding and ensure adequate ventilation, which helps to prevent overheating and potential damage to the conductors. In addition to the NEC requirements, it's also important to consider any local codes or regulations that may apply to the installation. Local codes may impose additional requirements or restrictions that are not covered by the NEC. It's essential to consult with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. When selecting a raceway for an underground installation, it's also important to consider the environmental conditions to which the raceway will be exposed. For example, in areas with corrosive soils, it may be necessary to use a raceway that is specifically designed to resist corrosion. Similarly, in areas with extreme temperatures, it may be necessary to use a raceway that is designed to withstand those temperatures. It's also important to consider the potential for water intrusion into the raceway. Water can damage conductors and other electrical components, so it's essential to use a raceway that is watertight or that is properly sealed to prevent water from entering. In summary, the selection and installation of underground raceways must comply with the requirements of the NEC, as well as any applicable local codes or regulations. It's important to consider factors such as burial depth, backflow requirements, protection from physical damage, conductor ampacity, environmental conditions, and potential for water intrusion. By carefully considering these factors, it's possible to ensure that the raceway is installed safely and effectively, and that it will provide reliable performance for many years to come. Therefore, in this particular hospital context, because the electrical system involves emergency power for critical care, NEC 517.30 takes precedence over the general guidelines in NEC 353, emphasizing the necessity of Schedule 80 conduit for enhanced protection and reliability. Firstly, let's delve into the specifics of NEC 517.30, which addresses the essential electrical systems in healthcare facilities. This section of the code is designed to ensure the reliable operation of electrical equipment that is critical for patient care during power outages or other emergencies. Secondly, we need to consider the wiring methods permitted under NEC 517.30C3. As you mentioned, the section specifically allows for non-flexible metal raceways, type MI cable, or Schedule 80 rigid non-metallic raceways. The choice of wiring method depends on various factors, including the specific application, the environmental conditions, and the local code requirements. Thirdly, it's important to understand the rationale behind the requirement for Schedule 80 conduit in this particular application. Schedule 80 conduit is thicker and more robust than Schedule 40 conduit, providing greater physical protection for the conductors. This is particularly important in healthcare facilities where the electrical system may be subjected to physical stress or impact. Fourthly, it's crucial to recognize that NEC 353, which covers rigid non-metallic conduit, does not apply in this case. NEC 353 is a general article that applies to a wide range of applications, but it is superseded by the more specific requirements of NEC 517.30 in healthcare facilities. Fifthly, we should consider the implications of using Schedule 40 conduit instead of Schedule 80 conduit. Schedule 40 conduit may not provide adequate physical protection for the conductors in a healthcare environment, potentially compromising the reliability of the essential electrical system. Sixthly, it's important to consult with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. The electrical inspector has the final authority to interpret the code and to approve or disapprove the installation. Seventhly, we should examine the specific requirements for underground installations as outlined in NEC 300.5 and 300.50. These sections provide detailed guidance on burial depths, backfill materials, and other important considerations for underground raceways. Eighthly, it's essential to consider the environmental conditions to which the raceway will be exposed. For example, In areas with corrosive soils, it may be necessary to use a raceway that is specifically designed to resist corrosion. Ninthly, we should assess the potential for water intrusion into the raceway. Water can damage conductors and other electrical components, so it's essential to use a raceway that is watertight or that is properly sealed to prevent water from entering. Tenthly, we need to ensure that the raceway is properly supported and secured. The NEC provides specific requirements for raceway supports, which are designed to prevent the raceway from sagging or becoming damaged. In conclusion, the consultant is correct in requiring Schedule 80 HDPE roll pipe for the directional bore between the two buildings. This requirement is based on the specific provisions of NEC 517.30 C3, which governs essential electrical systems in healthcare facilities. The Schedule 80 conduit provides enhanced physical protection for the conductors, ensuring the reliability of the emergency electric pump.